Yeah, so I used to be here in Umeå until very recently, and now I moved to Heidelberg, and I work in global health, so do climate change and environmental studies in global health. My main focus nowadays is actually on infectious diseases, but I have been working on across the spectrum in climate and health. And climate health is a huge field. It incorporates everything, I'd say. And when I talk about findings and the field, one should be aware of that it's a selection of, it's not a comprehensive presentation, because we don't have a comprehensive understanding on, the effects and the impacts, I would say. We know a little bit. It's like we can observe part of the maybe less complex impacts, but a lot of the cascading effects in the society, I think we don't have a good understanding of yet. As an example, I could mention there was a paper recently in Nature Climate Change looking at infectious diseases. It showed that a majority of infectious diseases have some kind of climate sensitivity, documented climate sensitivity, and that climate sensitivity goes through more than 1,000 different pathways, only for infectious diseases. And then infectious diseases is only one part. Obviously, there's a lot of chronic diseases affected as well, and then there's even more pathways. So it's a very big and sometimes daunting task to actually research and try to bring some understanding into climate and health. So just to make it easy for myself, I figured I should actually probably talk a little bit around the Lancet Countdown, which is a big activity that maybe you've seen it. There's an annual report which we produce. There will be a new one in about a month's time, and it gives not a comprehensive picture, but it gives you a quite comprehensive picture of the things that we understand better, at least today, and it shows the trends on how where development is going, and it's the historic to current trends. It's very sort of human-centric in its sort of presentation, and that could be discussed, of course. So what I'm going to present here is not only my own indicators, although we contribute indicators into the Lancet Countdown report every year. I'm not the only one, so I just want to give a little bit of credit to other people. I also want to highlight this because there's going to be a new report coming out in exactly a month from now on health in Europe, which is a little bit deeper, actually, goes deeper into specific trends, indicators, patterns. So it's definitely worthwhile to keep your eyes open. It would also be published every year in the Lancet Public Health. And there will be a kickoff seminar, I think it's the 28th of October. Okay, so back to climate change and pathways. So climate change affects a lot. It affects CO2, it affects temperature, it affects hydrology, rainfall, droughts, floodings, etc. Extreme events are quite much, I think, discussed and quite easy to actually envision that you have society impacts from. Some other impacts are harder. So heat, for example, it's more a silent killer. And I would say also a lot of infectious disease impacts is also silent. We don't really notice it because it's sort of, gradually aggravating the current situation. So those are very different. So the sort of the shocks and the gradual changes are quite different in how it's affecting. And the shocks would be easier to actually also attribute consequences to if you have data, but the gradual increases are more difficult because then you need to do an attribution and separate climate trends, for example, from other trends in the society that could affect disease. And that for that you need to have certain methods, and modeling is one way of doing it, so that's what I specialize on. Yeah, okay, so the big groups of health impacts that we talk about usually is vector-borne diseases. It could be mental diseases, it could be food system-related diseases and nutrition, diets, etc. And chronic disease or cardiovascular diseases. And this is, again, just a sort of overall description of how it links up. I'm sure this description and this image is not complete in any way. There is a lot of complicated pathways that would not be possible to describe in a simple way. But I think still this captures the big and the more important pathways. It's heat and health, health and extreme weather, climate-sensitive infectious diseases, food security, undernutrition, and migration, displacement, and that could be as a consequence of various climate-related issues, but for example, floods and sea levels. To go into some of the observations, this is a vulnerability graphic that we've actually produced. It shows how people are increasingly susceptible to heat-related diseases, and heat-related diseases usually chronic. If you have pre-existing diabetes or other chronic diseases, cardiovascular disease, if you live in cities, and if you're older age, you usually have a predisposition to be more affected by heat and have higher risk of heat mortality. So this is showing in according to groups of the Human Development Index. It shows basically where the development is taking us currently. And I don't think this would be a surprise to many that we're actually getting more susceptible to heat, and it's mainly because of urbanization and older populations with more chronic diseases. The rise is quite strong, so this would definitely make populations in most places of the world, actually, as it looks, actually, all of these regions more sensitive and susceptible to heat exposure and heat-related mortality. So if we look at the heat exposure in itself, we could also see trends. We could see trends among people over 65 years of age. And we can see trends in populations under 1 year of age. So these are two groups that are susceptible to heat exposure. And the distribution of these exposures and person months of exposure is different. Person days of exposure is different in different countries, and depending on the demographic structure and depending on the exposure. But the overall trend is definitely going up. So we have more sensitive, susceptible populations, and we have more of these type of event exposures, which means that we can expect more mortalities and morbidities from these exposures. There is another important indicator described here, which is actually how we are potentially affected by increasing heat in restricting our safe periods of outdoor exercise and also sort of heavy manual work. And that's also actually going up, so there is more and more hours in the day in all of these regions as well, and especially in the low Human Development Index region, where you have basically less hours where they're safe to exercise or do heavy labor. And that's a quite clear trend as well. There is also potential work. This is an estimate, that's why it says potential. But there is an estimate of a large number of work hours lost due to heat as well. And specifically in low human development index, so poorer areas, this estimate is higher, and in the agricultural sector in those areas. So that's definitely an interesting, going to the theme of the conference. I think that's very interesting and important because you have a lot of consequences from reduction in productivity indirectly on health and the economy, society, livelihoods, etc. While it's the populations in the low human development index regions who's most affected, it's not them who actually emitted most of the emissions, but they are more susceptible, and the society as a whole is likely to be impacted by this. Another indicator that's shown here is actually expressing, is an indicator. There is no actually yet so far good estimate of how we are sort of affected mentally and well-being wise from exposures and climate. There's a lot of different pathways from exposures like floods or heat where you would expect actually mental health impacts, but there is no good indicator yet that we actually can talk about and present. But there's this indicator from social media, which is interesting in a sense because it captures something maybe more subtle. It shows that during heat exposure periods, there is more negative sentiments in social media, in this case Twitter. So there seemed to be like a short-term relationship between negative sentiments could be those that are aggressive also with heat exposure, and it's also been well known for a long time in the heat literature that you could actually tend to be more aggressive in situations when you're under strong heat exposure. But this is just indicating then that we also see an increased, at least short-term trend from 2020 up, although it varies a little bit. It does sort of relate to heat exposure because that's the negative sentiments in association to heat exposure. With a lot of new data sources like social media and other sources, there's quite a lot of possibilities to actually deepen these type of analysis. I wanted to talk about this study as well, so I'm not only talking about Lancet countdown indicators, but this was a study that was published maybe half a year or a year back, and it basically shows that if we look into the associations and the heat-related mortality associations, and then we compare that to climate, which would be prehistorical. So basically, if we in a model use a prehistoric climate today, and then we look at the difference in terms of the heat-related mortality that we attribute, then we would already now estimate that 37% of those heat-related mortalities that occur today would not have occurred in the prehistoric situation. So this is a little bit theoretical because there's obviously no possibility to assess this without actually making models and model predictions. And there is no Earth where we have the prehistoric climate today. But it's an interesting comparison still because I think this is probably about the best you can do in terms of understanding the difference between prehistoric climate conditions and current climate conditions, and how much we've actually contributed to that in anthropogenic warming, and how much that spills over into heat-related mortalities. Okay. Wildfires is also something that's increasing quite a bit, and wildfires could also have a lot of different health impacts, not the least the smoke that usually large populations are exposed to during wildfires. But also, obviously, the social, economical impacts from maybe properties and houses and insecurity, etc. So 60% of countries had an increase in the number of people exposed to very high or extremely high danger of fire in the last years compared to early 2000. This indicator doesn't actually show the smoke exposure and populations exposed to smoke and attributes mortality to that smoke or pollution. But there will be an indicator in this new European report that's published in a month that actually captures that better. And hopefully we'll have better estimates onwards to describe also pollution impact. Yeah, and you can see the distribution is really not really even in these impacts, which is also a little bit like this labor productivity, for example. A lot of the impacts are expected generally to be not only for fires, but generally to be in populations where you have a low degree of development, so low development index, where you have more susceptible people with less ability to adapt to these exposures. Yeah. There's also droughts. So 19% of the global land surface was affected by droughts in 2020. This doesn't actually, the map only describes 2020. You see quite a large number of areas with drought conditions. Be interesting to look at the updated map for 2022, given that there's been a lot of such situations recently. And according to the trends to the left, you could also expect this to continue, really. It's quite a strong pickup in the last decades. And that's in a bit the same for most of the graphics we look at. We see that kind of strong pickup in terms of exposures and health impacts over the last 20, 30 years, and corresponding to the warming. Here's another number of indicators. This is a little bit crammed in. It's infectious disease indicators. So you see, for example, Vibrio exposure, which is common in the Baltic Sea and also along the east coast of the US and North America. The Vibrio bacteria is actually abundant in most of the waters, in brackish waters, for example, where there's a little bit lower salinity. And when the temperature gets high enough, it grows, and then it can affect, either it can affect you through through seafood, which is very common in the US. You get a lot of infections of Vibrio, which could be quite severe from oyster consumption. But we also have a rise in cases in the Baltic, and that's rather more related to direct exposure. So you get exposed into wounds, etc., and can get severe complications like septicemia and necrotizing wound infections, etc. So that's one, and then Vibrio cholera. The Vibrio is actually showing very strong trends, and it's very climate sensitive. Looking at the Swedish data, you have peaks really coinciding exactly almost with the the warmest years. You see big jumps in from year to year depending on the summer temperatures and the sea surface temperatures. So that's one consequence. We have cholera as well, where you see a little bit lower trend. Cholera, this indicator doesn't actually capture secondary transmission through the fecal-oral route. It actually captures more the reservoir conditions for cholera and for cholera spillover into human populations through sea surface, for example, in more tropical areas, but that's also changing, and in some areas increasing in suitability. Malaria is one important climate-sensitive disease as well. It still kills a lot of people, and mostly children. Malaria is it's more complex in its relationship to climate because it's a little bit sensitive also to heat. So you'd actually expect malaria in the future. You would expect it to actually probably have lower suitability and R0 or potential for transmission in some of the African regions. While still, because it increases its suitability in the highlands, you'd have a much larger population at risk. So even if you see that type of compensation, you see a much higher risk overall because it increases up in the highlands. And it's quite problematic in a sense because then you actually have more emergence and suitability of malaria in areas where you don't really have had exposure to the same degree throughout your whole life, and that could cause a new kind of epidemiological different situation because there's some protectivity with having been exposed before. So that's really something that's not measured here, but an additional layer that we need to consider. Dengue has been expanding hugely over the last 30 years, and it's one of those diseases that's driven by human activities. So mobility, definitely a very important driver of dengue, and climate conditions in its emergence. Thinking about expansion of a disease, you need several things to sort of interact to lead to that expansion. And you wouldn't have any emergence of dengue unless you have suitable conditions for the mosquitoes to replicate virus and to spread it to humans. It's a necessary condition. So there is no actual emergence without suitable climate. And climate is becoming more suitable in a lot of locations. So here, this is the global, again, description of how the R0 is actually picking up over the last 3 decades again. And during this period, the incidence has also increased hugely, the global incidence. But then mobility is also part of shaping that scenario. So in thinking about what climate creates as risks in the future, it's also important to consider the co-acting factors. In this case, both emergence and transmissions like hyperendemicity is going to be fueled by climate and mobility mainly. And those would both probably increase, I assume, in the future quite a bit. So we have, in a sense, 2 different synergistic effects to adapt to. And it's going to continue changing quite a bit onwards. This is a projection that we did a number of years back, which shows dengue vectors and the abundance of dengue vectors and how the population, the mosquito population numbers. Mosquito population numbers are obviously important in the transmission dynamics. And this projection shows in the future how it's likely to continue to increase, and depending on the climate scenario. So if we have less mitigation of climate, then we'll have much more vectors, up to 30% more in average globally. So that's a huge number. There's large areas in Africa, in southern part or mid-southern part, where you have much more suitability and abundance according to the models. And if we manage to go for something similar to the Paris Agreement, you will level out in 2040 or 50 or something like, and have still a quite big increase in abundance, but not as big. So this is obviously also very important to consider. We usually look at these trends here in the indicators with the Lancet countdown up to 2020 or so, but it's likely, according to this projection at least, it's likely that that trend will continue for a number of years. And it also looks likely that whatever we basically do, we're going to face a situation with continued warming up to a couple of degrees, and that's going to mean that you have much more vectors, you have much higher reproductive values, and more fearful outbreaks and emergence in new areas. Just want to mention something else when talking about infectious diseases, which is probably going to be incorporated in among the indicators onwards in future years. It's these complex pathways between spillover, deforestation, which has both a mitigation side with Amazon forests, and it acts as a sort of carbon sink, and you have these effects on the viruses and pathogens, where you have more replication, which is sort of directly related to climate. Plus, you have impacts on animal species would need to adapt to climate change as well. They usually do adapt to new situations. Some of them might not be able to adapt so efficiently, but in that adaptation, you're going to have a lot of cross sort of animal species sharing between different animal species, and you might have much more spillovers to human as well, because you have more mixing of different species. That's likely to happen. Over the last 100 years, there has been more of these type of events. It's probably not so much driven by climate, but honestly, we don't really know, I would say. It's quite complicated pathways to study and complex systems. But this is really important, and it's really important to actually describe and understand how both our impacts on the mitigation and the carbon sink, deforestation and biodiversity is leading to more of these type of spillover events, which could lead to zoonotic emergence or pandemics, but also to understand actually the impacts and how that's also species distributions and transmission potential and potential health impacts, how that's affected by the warming, which is not described. So IPCC, for example, doesn't describe these type of events much at all. It's really, and the One Health panel and doesn't describe climate change so much. They talk about biodiversity, environment, but like there's a little bit of, siloed approaches and assessment in that sense, I would say, at least. This is a rather new study from Nature, where people looked at this type of species distribution impacts. So they looked at over 3,000 mammal species and estimated how they would redistribute in the future climate in 2070. And then they also looked at the genetic expression of the viruses that these mammals are known to carry, and looked at whether those viruses would also be potentially jumping from one mammal species to another if the mammal species had shown susceptibility to that virus. And based on this analysis, they estimated that there will be, just due to climate change and land use change associated with climate, you'd see maybe up to 4,000 more times more of these type of cross-species viral sharing. And that's also happening in locations where humans are much more abundant. So it's quite likely that that would also spill over. Some of these would also spill over to humans and cause zoonotic emergence and potentially even new pandemics. Okay, so there's also impacts on the food system, and the food system is obviously a very big sector. So these are predictions based on models which have been calibrated by a lot of data, of course, indicating that maize could reduce by 6%, wheat by 3%, soybean 5.4%, or have been reduced now compared to 81 to 2010. So that's a quite big change for a short period, I would say. What's also actually interesting in the food system and health is that there are studies indicating that because of the increased concentration of CO2 in the atmosphere, we'll have lower micronutrient contents in these type of crops. And that means that we'd have less proteins and other important sources of micronutrients and especially people in low middle income countries where the Human Development Index is low, is much more susceptible because they depend to a larger extent on these micronutrients in their daily intake. So there are studies actually estimating future huge increases in morbidity across a range of diseases just because of these micronutrient reductions from the CO2 rise. Sea level rise is also very important, obviously. It's difficult to estimate the direct health impacts from this or the indirect health impacts from this because it's such a big topic. But we can expect a lot of people to migrate somewhere else if the sea level rises up to 5 meters. You see a huge impact. Okay, so next thing, I only have a few slides. I think I'm running out of time soon, right? Yeah. So next thing is basically how well do we adapt to these situations? And the adaptation plans and strategies is in different countries is really lagging behind. So there's much less done in terms of adaptations. And also looking at studies, there's much less studies on looking at how we effectively can adapt to the situations, what interventions would be most effective and so on. And also if you look at from the global perspective, again, there's very much high income regions to low income region gradient here. Another indicator that comes out, which is also part of the European report, but the global here as well, is the transport related. So basically emission, pollution related deaths in air pollution, which is very much depending on our combustion of fossil fuels, car traffic, for example. And those numbers are very large, distributed across sectors. So agriculture is also one important, transport, industry, etc. Very large numbers, which are very much depending on emissions from fossil fuel. If you look at a specific sector, there are solutions, and transitions would obviously mean that we have large gains in terms of health impacts in this domain. So this is referred to as a co-benefit of mitigation. These indicators that show reductions in mortalities, for example, due to cutting emissions are referred to as co-benefit indicators. There's a similar indicator for nutrition, which is actually showing the potential gains of health impacts related to diet and nutrition, and at the same time how much of our food consumption that's actually contributing largely to CO2 emissions. And it's probably no surprise to anyone here that meat consumption and red meat consumption is very big. It depends also on where the meat comes from. So if the meat is actually from Brazil, and you've also had deforestation associated with it, you'd expect maybe even larger impacts. So this is also a very important opportunity to actually gains and to find these transition opportunities. So it's not only the impacts from the exposures itself, it's also the potential health gains of making the transition we need to make in order to reduce emissions and to change our path. Last thing I wanted to talk a little bit about is that there's a lot of studies, increase in studies. There's not a lot of studies, but there's quite a large increase in studies and research activity in this field. But it's also, again, very uneven when you look at the tropics and the high-income countries to the low-income countries. So really where we expect, again, a lot of the impacts to be, and where we expect a lot of the adaptation and vulnerabilities to be largest, there's much less research. So this is obviously also an ethical issue. How can we really adapt? And it also has a little bit of a colonial type of side issue, given that there is not really enough local researchers in places where we expect most of the impacts to actually develop adaptation, develop ways to cope with the stress. That said, there is obviously a lot of global issues that need to be tackled, and that could help a lot in terms of cutting emissions and transforming food systems, etc. I think my main ethical perspective is, which you might have noticed, is very much this sort of low middle income country impacts versus us actually having been the most contributing most to emissions and contributing most to the situations, and maybe also gained most from emitting in terms of our welfare and society. And that obviously, I think, is a very, very important consideration in how we tackle this. So I hope that gave you a little bit an overview on where we stand today. It's not comprehensive, as I said. I think even the presentation here, I have the feeling it's just the tip of the iceberg that we can actually see, and that's much more, obviously, in terms of the complex impacts and systemic impacts, that's very difficult to describe. Thank you.
Thank you very much, Joakim, for addressing these important points. Are there any questions from the audience? I will bring the microphone to those who would like to address a question. Yeah.
Hi, thank you for a very nice talk. You say that your ethical takeaway from this is, I understand it, fairness, that the countries most affected are those less, that didn't cause the climate crisis. How do you think that can be dealt with? Like, how can that be solved in a sense?
I think one thing is our responsibility and sharing of our wealth, because we've actually benefited largely from this development, and the economic development has been very much depending on fossil fuels up to today. So one thing is also obviously, but then there's this colonialism issue, which is difficult. We had this discussion before on how do you actually, do you have enough capacity, and how do you build capacity to cope with this? It's not a simple issue, I would say, in the end. But I think we have a large responsibility in causing a lot of the crisis, and also maybe responsibility in solving it and scaling up solutions, which is not only for us. I don't know if maybe you have thoughts about that.
Yeah, but I also think it's interesting that, as I understand, you say that it's also a financial issue, that those who were a bigger cause should then pay for that damage. Makes a lot of sense. I just think it's a hard pitch usually to the countries with money are not so keen on kind of lowering their living standards or of moving their funds into the countries more affected.
No, I agree.
So I think that you have to find an incitament for that, but I don't have a great answer. I agree, but I think it's complicated to push them into that.
Yeah. It is complicated, I'm sure.
I had a very tiny question about the things you said about the food system and how the CO2 emission affected the micro and nutrients in the food.
Yeah.
I was wondering how, if you knew.
It's in the growth. I think mainly because it goes faster with higher CO2. So the growth of a lot of these crops actually faster, and then it generates less of proteins and zinc and micronutrients. That's very important for children, for example, growing up and having more of a crop-based daily diet. I'm not a dietist. So
no, but it makes perfect sense. I just didn't grasp the path.
Yeah, so it's a different pathway. It's from the CO2 concentrations, basically.
Thank you for a very interesting talk. You didn't mention conflicts or war. Could you speculate on that climate change as a driving force for military conflicts and war, if we look at, for instance, Syria and now Ukraine? Do we face a future with increasing military conflicts because of the climate change and the migration and impossibilities for people to stay where they have been because they can't support themselves, and what we already are seeing? Have you been able to model anything like that?
There's a study actually on which associate conflict to climate extremes in Africa. I think it was from the Potsdam Institute of Climate Impact Research. It's difficult to study empirically, but I mean, if you just think about it, it's quite apparent. Like if you don't have water, if you don't have food, it's unstable. The governance would be unstable, and you probably see this type of impact for sure. And they would have cascading effects. They would have systemic effects, and so on. So It's just at a different level than I'm more of an epidemiologist. But I do realize that health depends very much on those effects as well. That could be geopolitical. So I think it's also a very, very important issue to be aware of. And I think it could be described better, actually. And probably it has been described. I would be surprised if not the military, at least, is also considering this as a real potent threat in geopolitical politics and military. So that's, yeah, no, it's definitely a very serious issue.
Yeah, my name is Theodor Christensen, also on the committee from Iceland. Thank you for a very good talk. And I have two questions. One is about the crop yield potential reducing. Yeah, one of the studies you told us about. Does that reduction in potential take into account the possibility of new areas becoming possible areas for yielding crops where it was too cold, for example, or too something else? Climate was not suitable before. So that's one question. Another one is more like ethical, because so if the industrialized countries who have already benefited a lot from the sources of climate change, they have maybe two major obligations. One is to transition to sustainable energy sources. That's a huge task. And the other is to mitigate the consequences, not only in their own countries, but primarily in other countries. And perhaps also allowing other countries to time to develop, and so not apply the same standards. So these are two great tasks that I think are ethically important, and I wonder if you agree and how you would prioritize these two. So, yeah.
Very good questions. Yeah, I think for the food crop, it's the ones I was showing is biological, and it's aggregated for the globe, so it actually shows the net effect. And if you zoom into a specific region, a specific locality, you'd see different. So you'd see, obviously, that you can probably grow more things up north, and in some areas which are already stressed in terms of water and heat, you might have a lower potential. But you might have another potential if you change to another crop. So part of adaptation is also thinking about what would we actually need to do different now when we think about what crops to plant where. That's one consequence. Another thing, it's that indicator is insufficient in itself because it doesn't actually include these productivity agriculture components, for example, with heat. You'd also expect probably to have a reduced productivity for periods at least, and maybe I'll be working in a project with Burkina Faso, which is quite hot. It's quite dry. Periodically, at least, they have floods as well. But and in those situations, actually, the people, which are usually women working in the fields, subsistence farmers, are quite a lot affected by the heat. So the productivity goes down during those periods, and that's also something that should be considered when you think about food production. I think, unless we're thinking of having robots doing everything, I don't know. But yeah, so that's quite important. The other question about adaptation versus mitigation, or mitigating the impact, first of all, we don't have a comprehensive understanding of what the impacts will be. So there's large uncertainties in terms of actually dealing with something that we don't really fully understand. I think that's important to consider. The other thing is that there's limits to adaptation. So even if we adapt as good as we possibly can, we're not going to be able to adapt perfectly, I think. And the IPCC in its last report from 2014 had limits to adaptation graphic. And if you look at different pathways of diseases specifically, some of the heat impacts are going to be very difficult. And some of the infectious disease impacts we don't really have currently, at least, a lot of good tools to adapt to. We can do part of it, but not all. If you think about then mitigation of climate change, that would be going to the root type of prevention. Yeah, so I would throw my dollars into mitigation of climate change as much as possible currently, but at the same time try to do as much as we can about the impacts and consequences. And then we don't know about geoengineering, etc. Maybe that would also be a solution, but that would have other ethical dilemmas, I think, which is also interesting, because I have the feeling that at some point when this would actually accelerate, people would just accept to do geoengineering because it would be such a stress situation, but I don't know. The discussion is not really reflecting that today, I think. But I think in political decisions, it would be maybe even, yeah, it would be a different situation in the future.
Thank you. I would like to ask something more, perhaps within the area here that you talked about, and I'm not sure you mentioned, but I'll ask the question anyway, and has to do with the diseases. And I was wondering, diseases usually connected to local areas where also climate change is mostly affected. Could we potentially see spread to other areas where they have not been known to exist before? As it gets warmer, it may spread through in different ways, through animals, also spread through humans with perhaps mass migration, and to areas where there hasn't been very hospitable for certain, I'm not sure, bacteria or mosquitoes and so on.
Definitely, yeah, absolutely. So basically disease emergence would be certain types of disease. I mentioned this study on infectious diseases where a majority, I think 57% of all infectious diseases that they've actually went through in this Nature publication was actually had some kind of climate sensitivity. So that means, and if it's driven by animals or mammals, for example, as hosts, or mosquito vectors, it's definitely climate sensitive. And you would expect emergence when climate reaches certain thresholds, and then over those thresholds increasing transmission pressure. It's not the only thing. Usually you depend on migration as well. So it's an interaction when it comes to emergence of migration of humans or mobility, or even bird migration. So West Nile is an interesting example for Europe, where we have an increased frequency of human cases in some areas. It's definitely moving northwards and expanding at the moment. It seems to be very much driven by climate, but it's also depending on bird migration, for example, and local mosquitoes. But the mosquitoes for that specific disease are abundant. It's just that they in much more areas than where the virus is. It's just that they're not capable, because the climate is not enough suitable. They're not capable of actually replicate and transmit the virus and grow in numbers, etc. So very much so.
May I ask a follow-up question?
Yeah.
Is there any rough number on when we expect to see such
emergence?
Yes. Yes.
It depends on what disease you look at, because they function a little bit different in their climate sensitivity. And but what you can do is you could use these climate scenarios that I was showing before, and then if you have a model that can well describe the epidemiology in relation to climate, and maybe including mosquitoes and animals, then you could start making risk assessments for areas and emergence. And I think that's one way to guide adaptation in the, a decade or 2 or 3 from now, for example. So there's some studies on that. We need much more. but it's possible to prepare a little bit for those, for some of those at least, and then some of them are much more complex, of course.
Thank you.
Thank you very much. Excellent talk and answers, Joakim, and the audience. Thank you for relevant questions. So,
the questions was very interesting.
Maybe you should give him a big applause again.